Hello, and welcome to another edition of AppSec Decoded. I'm Taylor Armerding, security advocate with the Synopsys Software Integrity Group, and today we're going to be talking about malice, as in malicious packages. Not the physical kind that could be left on your doorstep, but the digital kind, which are designed to let attackers penetrate and create havoc within your organization and potentially with the products you sell. And joining me to talk about it is one of our go-to experts on the topic, Mike McGuire. He is Senior Software Solutions Manager with the Synopsys Software Integrity Group, and he's played a major role in the creation of the recent Synopsys ebook titled Exploring the Threat of Malicious Packages in the NPM Ecosystem. Mike, thanks very much for being here, and let's get into it and start with the basics. What are malicious packages? And what kinds of damage can they cause?
Sure. So malicious packages, it's a pretty broad term, but at the end of the day, it's a package that consists of software or code that is not broken. It's not a bug. It's not vulnerable, but it is intentionally doing bad things that can impact the developer of the software, the operator or user of the software, whether that be the organization that's deploying it or even the end user of that application. Now, what makes it so dangerous is it can do a bevy of different things. So it can do things like install other bad, vulnerable, malicious dependencies. It can steal sensitive information and leverage that, send that over to threat actors who can then sell it, right? And this can be sensitive information about the operator of the software or the end user of the software.
The ebook has chosen to focus on JavaScript, which is not the only player on the block. But why did you do that? Why did you focus on JavaScript?
Because the answer is very simple. JavaScript is the most widely used popular programming language in the world.
Okay.
I read it once. I'm not sure. I can't recall where I read it, but there's this common saying out there that if something can be programmed in JavaScript, it eventually will be programmed in JavaScript. There's a lot of pros and cons to JavaScript. A lot of people, developers, either love it or they hate it. There's some in between. There's time for it, there's time not for it, but that doesn't take away from the fact that, again, it is the most widely used programming languages. As such, that makes NPM a very, very large ecosystem or package manager. And this has, as such, become a target for a lot of threat actors and has become the hub for a handful of malicious packages in the most recent past.
The paper goes into detail on 4 of the most common ways that attackers create and insert malicious code into packages. And so we're going to ask you to talk about what each one is and how it works. Okay. And door number 1 is brandjacking.
Sure. Yeah. So brandjacking is, again, put simply, where I'm taking advantage of the good reputation of a particular name, and I'm using that to leverage people's trust and insert malicious packages or code into their applications that way. So if you, Taylor, are a maintainer of a popular component called htailor, then I might make a component called htailor-stream. And people who may be working fast or are just otherwise unaware of some of the risks, and they're not taking time to due diligence of the origin or reputation of that particular project or component, will go through, download that, where it might do things similar to htailor, might do identical things as htailor, but it adds on some malicious aspects that might be pretty difficult to identify, detect, and suss out.
All right. Second is typo squatting.
Sure. So this is where it's different than brandjacking because but similar. So it looks like the original brand, but it differs so much, a little tiny bit, where I think I'm downloading htailor, but what I'm actually downloading is hyailor or something like that, something very similar, where I went online, a quick glance looks just like it, or it's one letter next to another on a keyboard, and actually T and Y are next to each other on the keyboard as I'm looking at it right now. So that's a common typo for it. So I actually inadvertently download that package instead of htailor. And again, it's doing something very similar. So I wouldn't notice right off the bat that this is not what I'm looking for, because it's doing the job that I'm looking for. But again, it's got a malicious aspect to it.
All right. Number 3, dependency hijacking.
So this is me actually going through and hacking your account. So you are the main maintainer of htailor, and your credentials aren't secure, or you're not using two-factor authentication within, let's say, GitHub, and I'm able to somehow find your credentials or do a brute force attack, get my way into your account, and maybe approve some sort of pull request from my other account where I did fix something or enhance something, but again, there's a malicious aspect to it. Or right then and there, I program in some way to call to a remote IP address or collect sensitive information or just completely sabotage an application, whatever it may be. I am posing as you because I was able to break in to your account.
Okay. And finally, dependency confusion.
Yeah, this one is big, right? We saw a couple of years ago a big article about this, how a white hat hacker was able to find their way into a lot of big name software organizations and technology organizations through these means. So if I am a Mike Software Inc., I have an internal private repo. So it might not even technically be internal, it's just a private repo of open source dependencies that I'm using. Now, I use a lot of dependencies. So I default to, if there is a new version of this dependency available, maybe just a minor version. It's tough to just automatically go up to new major versions because of downstream impacts. If there's a new minor version available, I want my package manager to automatically download and update us to that new component, that new version, because we want to stay on top of this stuff. We're not interested in tech debt. We have a lot of open source components. It's important to not let this get out of hand. So what happens is a threat actor may publish a component that has the same name of that private component within my organization, and it's one version newer or one minor version newer, and the package manager in my organization, as it's scanning the ecosystem, picks up on that. It's doing its job, it's keeping it updated, and it goes and grabs that from a public repo and pulls it into the private repo, and then replaces what was secure with the newer version, which now is insecure. Now it's malicious. And now that threat actor has their backdoor into my applications, into my build systems. So that component may not be malicious, but now they have that sort of backdoor and that visibility to get malicious components and behavior into my applications, into my customers' environments as well.
Right. And thanks to you, our audience, for joining us. Once again, this is AppSec Decoded. And until next time, I'm Taylor Armerding with the Synopsys Software Integrity Group. We help organizations build trust into their software.